Hello, good afternoon, students. Welcome back to Botany first year's class. So we are going with the SAQs from the 6th chapter and the other chapters. We have finished the till 6th chapter, all the SAQs except the 5th chapter, because 5th chapter we are having only the LAQs and the VSAQs. Okay. Now we have to go with the 8th chapter. We have started with the 8th chapter SAQs also. That is the in that SAQs also from the 8th chapter, we have seen the how to write the answer for the floral diagram, and the next one is the we have seen the first question, that is the describe about the floral diagram and the floral formula, that is the one, and the next one is the non-essential floral parts of Fabaceae also we have seen. Next, the floral diagram, give the description of the floral diagram, this also we have seen. Now we will go with the next one, next most important question, that is the describe the essential floral parts of plants belonging to Liliaceae. So when we are talking about the Liliaceae family, so this is the one what we have to remember a lot of things over here. The Liliaceae family is a monocot family, and here calyx and corolla are not present. That means there is no distinction between the calyx and corolla. So what we will call them as the perianth lobes. Okay, and the flower is a trimerous flower. 3 petals, 3 sepals. Actually, what we'll say trimerous, but here no petals, sepals distinction. So 3 perianth lobes are present in 2 whorls of 3 each. Okay, so what he asked, essential floral parts. Essential floral parts means only the androecium and gynoecium we have to talk. Okay, so androecium is the male sex organ. So the essential floral parts of Liliaceae are the androecium and gynoecium. Now comes with the description of the androecium. Androecium means stamens, male sex organs in the flower. So here stamens are six in number, arranged 3 plus 3. Okay, arranged 3 plus 3. That is 3 in each whole. Okay, 3 in each whole. Whole means a circle. Okay, in one circle, 3 in the inner circle, where the rest of the 3 stamens are going to be present. That is the 3 plus 3. So that is what we can say. Their stamens are 6 in number, arranged 3 in each whole. In the bracket, we have to write it as 3 plus 3. Next, we have to go with the how the stamens are, okay, and how they are present. They are fused with the perianth lobes, or in some plants those are free. That is, whenever they are fused with the perianthropes, that condition is called as the epiphyllous. Epiphyllous. If you remember this word, you can write this epiphyllous word. Otherwise, you can write the word, that is the sentence, fused with the perianthropes at its base. That is the epiphyllous. In that, one word is the epiphyllous condition, what we can say. Okay. And the next one, now we have to write about how the stamens, that is the anther lobe. The anther lobe is dithecous, basifix, intros. Okay, dithecous, basifix, intros, and the dehiscence occurs in the longitudinal manner for the anther lobe. That much. So, how to draw the diagram? We will discuss. I'll draw the diagram also. First of all, we'll finish it off with the gynoecium. Next one is the gynoecium. Gynoecium means the female reproductive part of a plant body. So here, what we have to write, the gynoecium is tricarpellary, trilocular, syncarpous, superior ovary. Tricarpellary, that means 3 carpels are present. Tricarpellary, trilocular, that means 3 locules are present. Syncarpous means all the carpels are fused. Syncarpous, superior ovary. That is, it is present above the thalamus. Okay. Tricarpellary, trilocular, syncarpous, superior ovary. This words has to be said with the comma. Tricarpellary, comma, trilocular, comma, syncarpous, comma, superior ovary. After this, what we have to write? After the superior ovary, we should write how many locules are, how many ovules are present, and how in this, how many, how they are arranged. The arrangement of the ovules also we have to say. So in that, the many ovules are present in each locule with the axile placentation. Axile placentation. Okay, and many ovules with axile placentation. Many ovules with axile placentation. What we have to say here. And the style is terminal, stigma is capitate and trifid. Okay, these are the ones. Now we have to show each and everything with the diagram. Here, diagram is very, very important. What we have to learn. Okay, in the material, in some materials, they have given the diagram. In some materials, they have not given the diagram. Then also, we need to draw the diagram for this, because where we can show the anthers, and that is the stamens and the stipule. Okay, that is the carpels and the ovules placentation we can show. So we have to draw the diagram. The first one is the andration. How to draw this? We can draw the illets of flower of the Liliaceae family. Okay. This is the first what we have to draw is the ovary, style and the stigma. Then we have to draw the stamens. Then we have to draw the flower. That is the perianth-lobes. Okay, like this, we can draw the complete flower. Okay. So here we have to give the labeling. This is the filament, anther, perianth-lobes, ovary, stigma. This is a style. This is thalamus. Okay, like this we have to draw the diagram for the androecium. Now comes the gynoecium. That is the what we have to draw here, ovary with the axile placentation. When we are saying this, how to draw this? Ovary is having the tricarpellary, trilocular, syncarpus. Na? See how easily I am drawing. This is the tricarpellary. That means the three carpels and the three locules are present with the axile placentation. Ovules are in the axile placentation. And many ovules are present. This is the one. So here, now start giving the labeling. Ovary wall, locule, ovule, okay, and this is the septal wall. See how neatly we did it. Okay, everything, whatever we have said, we have shown over here in the two diagrams, including the androecium and the gynoecium, everything we have shown. This is the way how to make the answer with the diagrammatic manner. So in this one, diagram also carries the marks. So be clear in drawing the diagram also. Okay, so this is the entirely TS of ovary. The heading is TS of ovary. Okay, now comes the next question in this. What is the next question? Describe about the essential floral parts of Solanaceae. Okay, when we are saying this, we have to go with the Solanaceae family members' essential characters. Essential characters of the Solanaceae means only the androecium and the gynoecium we have to discuss. Essential floral parts of Solanaceae are androecium and gynoecium. Now comes the androecium. Okay, so in this androecium, what we have to write? How many stamens are there and how they are arranged? Stamens are 5 in number. Stamens are 5 in number and attached to the petals at the base. That is called as the epipetalous condition. Attached at the base of the petals, there is a epipetalous condition. And they are present in the alternating to the petals. Otherwise, alternate with the petals. Alternate with petals. What we have to write over here. Okay, alternate with the petals and anthers. Now, here till now, here how they are present in the flower we said. Now we have to say how the anther lobe is present. And the anthers are dithecous, basifix. That means basifix means when the filament is attached to the anther lobe at its base. That is called as the basifixed intrors. Intrors means they will dehisce inside the flower. That is the one. So, androecium, in the androecium part, what we have to write? Stamens are 5 in number, epipetalous. Otherwise, if you don't know that word, you can write the filaments are fused with the petals at their base and alternate with the petals. And the stamens are dithecous, basifix, intrors. Done. No other point we need to write over here. No need. Now comes the gynoecium. Gynoecium means female reproductive part. Gynoecium. In the gynoecium, what we have to write? We have to write about the carpels and the ovule. So that is the bicarpellary. In this, the ovary is bicarpellary, bilocular, only 2 locules. Okay, bicarpellary, bilocular, or trilocular. Okay, and rarely bilocular, and in some plants it is unilocular. Example, capsicum. Example, capsicum, that is chili. In the chili, only one single locule will be present. That is a unilocular ovary. In some plants, it is unilocular. Example, capsicum. And the ovary is superior. Ovary is superior ovary. And the placenta, that is the septal wall, is having that is the swollen at the base of the ovules. Okay, placenta is swollen. Placenta is swollen, and this placenta is having the ovules are arranged in axile placentation. What happens after this? The placenta will have a turn of 45 degrees so that it will make the unilocular ovary into the bilocular, otherwise the bilocular into the trilocular ovary. Okay. So the entire placenta that is present as the swollen, this will be turning to 45 degrees. So that it will become the bilocular into the trilocular ovary. Okay, trilocular syncarpal superior ovary, what we can say, with the false septal wall in the ovary itself. So here we have to draw the diagram. So how to draw the diagram? For the androecium separate, for the gynoecium separate. For the androecium, we can draw the So these are the petals. Petals, anther lobe, filament. Okay, this is about the andrecium. Now comes the gynoecium. In the gynoecium, what we have to write? Only the tiers of ovary we have to draw. Tiers of ovary. Okay, so in this, first draw the circle. Then this is the center point for the circle. Then because of the false septal wall, 3 locules can be seen now. Like this. And all the ovules are arranged in axile placentation on this swollen placenta. Then it is having the inner wall. There is a lot of difference between the liliaceous ovary and this ovary. Okay. This is the swollen placenta. Now we have to give the labeling. This is the swollen placenta. And ovary wall. This is the locule. These are the ovules. That much. So whatever we have written and whatever we are drawing, both are equal, so that it's very easy for us to learn this type of answers. That is the essential floral parts of Solanaceae or Liliaceae. Okay. Now comes with the next question. That is the a brief account on the dicotyledonous. That is the class Dicotyledonate according to Bentham and Hooker's classification. According to Bentham and Hooker's classification. So in this Bentham and Hooker's classification, Dicotyledonate class is having the subclass Polypetalae, Gamopetalae, and Monoclamidae. Okay. So what we have to write? Bentham and Hooker divided the Dicotyledonate class into 3 subclasses. The first one is the Polypetalae, where the petals are free, and Gamopetalae, where the petals are fused, and Monoclamidae, where we cannot able to distinguish the petals and the sepals in them. That is called as the Monoclamidae condition. So like that, based on the petal arrangement on the flower, the subclasses were made for the class Dicotyledonate. And again, the subclasses were divided into series. Okay. And these series are mainly based on the thalamus, or how the thalamus is present. Is this having a disc shaped? Otherwise, it is having a flat shape. Thalamus is present like a disc, like that. So the original thalamus cup shape, like that. They have seen the shape of the thalamus, and based on that, again they have divided the classes, subclasses into the series. That is the Thalamiflorae, Disciflorae, Caliciflorae. So the Polypetalae subclass is having 3 series: Thalamiflorae, Disciflorae, Caliciflorae. Each and every series is having its own orders in them. So these orders are the ones what we can say as the cohorts. So what Bentham and Hooker did, the class is divided into the subclass subclass is divided into the series. Series is divided into the cohorts. Cohorts, now we are calling them as the orders. Okay, and each and every cohort is after that, each and every cohort is having the genus and the species. That's a different one. So families, genus, and the species. So till here only we have to write in this 4 marks question. So the Polypetalae subclass is divided into 3 series: Thalamiflorae, Disciflorae, Calciflorae. Okay, and the Thalamiflorae series is having the 6 cohorts in it, and the Disciflorae is having the 4 cohorts in it, and the Calciflorae is having 5 cohorts in it. And then the Gamopetalae subclass is divided into 3 series again: Inferae, Heteromerae, and Bicarpellate. Inferae, Heteromerae, and Bicarpellate. Okay, Inferae, where the ovary is inferior. Then the thalamus is having a cup-like structure where the complete ovary is present. That is the inferae, heteromerae, and bicarpellate, where the carpels are looking like the biliped. That is the bicarpellate. Okay, and each and every series is having the 3, 3, 4 cohorts respectively: inferae, heteromerae, and bicarpellate. Okay, so in this 3, 3, 4 cohorts. 3 cohorts in the inferae, 3 cohorts in the heteromerae, and 4 cohorts in the bicarpellate. Okay, and the last subclass in the dicots is the monoclamidae. The monoclamidae subclass does not have any cohorts in it. That is the series does not have. It is having the only the series. The cohorts are completely absent in the monoclamidae. So only series are present. That also 8 series are present over here. Okay, like that we can wind up this question. So here what we have to write, the class Dicotyledonnae is divided into subclasses and the subclasses, series, and the cohorts. And the Dicotyledonnae is having the class. It is having the 3 subclasses. That is the Polypetalae, Gamopetalae, and Monoclamidae. And this Polypetalae is having the subclass. Polypetalae is having the 3 series in it. That is the Thalamiflorae, Disciflorae, Calciflorae. And the series are again divided into cohorts. So that is the orders. Thalamiflorae is having the 6 cohorts, otherwise 6 orders in them. And the Disciflorae is having the 4 cohorts in them, and the Calciflorae is having the 5 cohorts in them. And the next class, next subclass, Gamopetalae. Gamopetalae is divided into 3 series. That is the inferae, heteromerae, and bicarpellate. Inferae is having 3 cohorts, and the heteromerae is having 3 cohorts, and the bicarpellate is having 4 cohorts. And the last subclass, that is the monoclamidae. Monoclamidae divided into only series. Cohorts are completely absent in it. That is the 8 series are present in the monoclamidae. Like this, if we have finished with this, then we draw this flowchart, then end up. So 4 out of 4 we will get it. And the last question in this chapter is the give an account of the economic importance of Fabaceae family. Okay, whenever we are saying the economic importance of Fabaceae family, so the first one what we have to write is these plants are these plants are having the great yield of the pulses. They will yield the pulses which are very rich in proteins. Rich in proteins. Example, red gram, Bengal gram, black gram, everything, all the pulses will come over here. Okay, these are the very rich in proteins. And next comes the second point in this. The edible oil can be extracted from soybean and the groundnut oils, groundnut seeds. Okay, edible oil. Edible oil can be extracted from soybean and groundnut as groundnut seeds as soya oil, glycine on soya oil and the groundnut oil respectively. Okay, and the next point, the oil cake is used as a fodder for the cattle. Oil cake means once we have taken out the oil from the seeds, then the solid material that left out, that is called as the oil cake. Oil cake is highly proteinaceous and that is going to be reused as the fodder for the animals. Okay, for the cattle. Oil cake is used as fodder for animals, for the cattle also we can say. Okay, next one. What we have to say next? Some plants are used as the leafy vegetables. Example, methi. We know methi leaves are used as the vegetable, leafy vegetable, and the seeds of the same plant are used in for making the spices. Methi leaves are used as leafy vegetable. Leafy vegetables and seeds are used as spices. Okay, and this plant is completely having the medicinal values in it. Next comes and we can make the green manure with sesbania. Sesbania and is used for making the green manure. That is the manure, and the fiber can be extracted from sun hemp. Fiber is extracted from sun hemp. Okay, and the next one. Timber yielding plants are more in this family as the example, red sanders, This wood is used for making the furniture, which is very durable wood. Okay, and the next one, the musical instruments can be made from the pterocarpus wood. Pterocarpus wood is used for making the musical instruments. Example, guitar, violin, and guitar, violin, veena. Okay, all these musical instruments were made with only one wood, that is the pterocarpus. And the next one, dye can be made, blue dye, yellow dye can be made from some plants, that is the indigofera. Okay, example, indigofera and the Butea monosperma. If you remember these names, then you can write. Otherwise, you can write it as the blue dye, yellow dye, like this, colored dyes. Okay, colored dyes can be made from some plants. Example, yellow dye, okay, and blue dye. Give the color, that is sufficient. Okay, next one. And fodder is going to be extracted from crotalaria, that is for the animals. Okay, fodder means the leaves which will give for the animals to have graze. That is called as a fodder. So here that fodder can be made from crotalaria and fasciolus. Fasciolus and crotalaria. How I am saying, how I am writing is same. Crotalaria. 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 Okay. Next comes with the okay. So with this, we have finished this complete chapter. Okay, where we can go with the VSQs also from this chapter. Because this chapter VSQs also we will get at any cost. One VSQ is mandatory. So here, see the VSQs, only 8 are there. From 8, you will get one VSQ. The first one is, what is omega taxonomy? Omega taxonomy. Omega taxonomy means when the taxonomy means classification of the organisms. Okay, when the organisms were classified based on their embryology, cytology, that is based on the embryos and the cytology, palynology, phytochemistry, serology, etc. Apart from the morphological characters is called as the omega taxonomy. That means what we have to write in a simple words, when the plants were categorized, otherwise classified according to the embryology, according to their embryo formation and the cytoplasm and the pigments that are present in them and the phytochemistry. That means based on the chemicals that are present in the plant body during the daytime, and based on all these things, including the along with the morphological characters, is called as the omega taxonomy. Simple words, you can use it. Okay. And next one, what is natural system of plant classification, and name the scientists who followed it. Okay, natural system of classification means the plants which are classified based on the importance of the morphological characters. Morphological characters along with all sexual characters is called as the natural system of classification. Okay, when the plants were classified based on the all morphological characters and all the sexual characters, that is in the brackets what we have to write, the number and the arrangement of the calyx corolla, and androecium, and the gynoecium, including the stamens are monothecous, dithecous, otherwise the intrors are extrors, and the gynoecium, that is the ovules, locules are how the locules arrangement and how many ovules are there, the placentation based on the placentation and everything we have taken into the consideration, and presence of ovary on the thalamus, everything they have taken into consideration for classifying the plants. That is called as the natural system of classification. This was followed by Bentham and Hooker. Bentham and Hooker. Okay. Bentham. Just now we read the short answer now. Bentham and Hooker. On what basis they have classified the dicotyledonate class? Based on the petals and the arrangement of ovary on the thalamus, polypetale, gamopetale, inferae. What we said just now, I said, na, same thing. We have to go with the 2 marks question. If you don't know anything, then also you can write like this also. That is also sufficient. Okay. And the third question. Explain the scope and significance of numerical taxonomy. What is meant by numerical taxonomy? When the plants were classified based on the mathematical calculations and the evaluation of their observations. That is called as the numerical taxonomy. Okay. So numerical taxonomy uses the mathematical methods to evaluate observable characters. That means to take the characters which we have observed, the differences and the similarities between the taxonomical groups is called as the numerical taxonomy. It's called as the numerical taxonomy. When the mathematical strategies were applied for seeing the similarities and the dissimilarities to take out between the taxonomic groups is called as the numerical taxonomy. And this is the completely based on the computers. So here we will use only the computers, and the code language also will use for feeding the data in the computer. Okay. Next one. What is geocarpy? Name the plant which exhibits this phenomenon. Geocarpy means earth. Okay. Carpy, when the fruits are produced under the soil, that is called as the geocarpy. Development of a fruit inside the soil, that is under the soil, not inside the soil. We'll call it as under the soil. Okay. When the fruits are developed under the soil, is called as the geocarpy. Example, Erachis hypogea, otherwise groundnut. Groundnut or Erachis hypogea. Whatever you feel free, you can write. Okay. And the next question. Name the type of pollination mechanism that occurs in the Fabaceae family. Yesterday, when we discussed about the arrangement of the petals, at that time only I said this is the one of the VSQ important in this. There is a piston mechanism. Piston mechanism. Okay. And next comes the floral formula of Solanaceae plant. Solanaceae floral formula. Floral formula of Solanaceae. So here what we have to write, this is the bracteate, comma, ebracteolate, comma, actinomorphic, bisexual, comma, calyx 5 fused, comma, corolla 5 fused, androecium 5 epipetales. Okay. And gynoecium 2 fused superior. Like this, we have to write the floral formula. Okay, bracteate Br, comma EBRL, comma actinomorphic, that is the circle inside that plus mark, and the bisexual, and the calyx 5 fused, corolla 5 fused, androecium 5, epipetalis, and the gynoecium 2 superior. Now comes the next person. Technical description of the ovary in Solanum nigrum. In Solanum nigrum, they have specified the plant. So Solanum nigrum ovary, we have to save over here. So in this, the ovary is in the Solanaceae, bicarpellary, bilocular, syncarpous, superior ovary. Everything you have to write over here. Bicarpellary, bilocular, syncarpous, superior ovary with the swollen placenta, and the ovules are arranged in axial placentation. Each and every locule are having more than 2 ovules in them. That's it. And carpels are arranged obliquely at 45 degrees. Okay, the placenta, the septal wall turns to 45 degrees so that the locules can be 2 or 3. Okay, that's the one. And the last one, give the technical description of anthers of Allium cepa. Allium cepa, only anther description we have to say. So the anthers in the Allium cepa, that is the Liliaceae family, what we have already described about the anthers in the 4 marks question. The anthers are, okay, anthers are 6 in number. What we have to say? Stamens are, remember here the answer is stamens are 6 in number, arranged 3 in each wall, that is a 3 plus 3, dicaecus, basifixed, intrors, and longitudinal dehiscence. Like this, we have to write the description for the anthers. Okay, so with this, we will complete for today's session, and we will meet you at the same time with the same channel for the more SAQs and the more VSAQs for the important examinations point of view. Okay, right? Thank you.